So in this demonstration, I'm going to write a structure of a do loop, which is an example of a counted loop, which will run for a specific number of times, and that we can determine before the beginning of loop, right? So I say program do loop, and I would say end program do loop. It should be saved as a Fortran file. Fortran file and the name. Okay. So just working with the default options, right? I would say I equal to 0. And if I write do while I is less than or equal to say 5, right? And I would say only print the value of I, and say it is equal to I. Since I is equal to 0, let me say I equal to I plus 1. So I have updated the value of I, and I would say end do, right? So it is going to print the value of I. Let me save this one. Well, it has already been saved. Now the time to test the program. So I have defined initialize the value of I equal to 1. Do while I is less or equal to 5. So I equal to I plus 1, and execute just the print statement, right? So let me compile it. Do loop dot for. So do loop dot exe. Okay. And to run it, I would write do loop dot exe. So we have the loop executed, right? So there are no problems. But this loop structure, while loop structure for integers, it seems to be slightly inefficient, right? The efficient structure, right, that can be constructed in this fashion. Let me make these lines silent. So to make these lines silent, I can write C in the first column, or well, that is conventional for Fortran to write C in the first column to make that lines of code silent, right? Or you can write the exclamation mark or the asterisk. They will make these lines silent. Now, other structure, Fortran 77 structure, to use a label, say do 10, I equal to 1 to 5, right? And I write here print asterisk, same statement, I equal to 1, print I, value of I. And over here, I will complete that block with the same label, and I will write here continue, right? This is the Fortran 77 structure. Do 10. So 10 is the label of the statement, and I varies from 1 to 5. Let's execute that one. Well, we have saved that program. And just to be very sure that this program is now executing these statements, so I write here running do loop structure. to make it clear that now this block of program is going to be executed, not the upper one, right? Upper one has been made silent. So compile the program and run it. So running do loop structure I equal to 1 and up to 5, right? Similarly, in this structure, say if you like to skip with the increment of 3, right? So for first I value would be 1, then with the 3 addition it will be 4. Now let's execute it. Compile and run it. So look for I values. So increment have been identified from the loop structure, right? Sometimes in calculations, you have to compute the terms of even terms, sometimes odd terms. So you can make that check from here, right? Similarly, you can run the loops in reverse order up to 1 with the step of -1, right? So at this point, let me leave this test for you. So test